Hello students, welcome back to the science class. In our previous class, we have studied about series and parallel combination of resistance. Today, we are going to discuss about heating effect of current. Whenever current flows through any conductor, some part of electrical energy gets converted into heat energy. This effect is known as heating effect of current. Suppose in any circuit, charge Q flows, suppose charge Q flows through any conductor on applying potential difference of V volt. Suppose Q charge flows through any conductor on applying V volt potential difference. Then work done by the source, work done by external voltage work will be equal to charge into potential. Also we can write that charge is equal to I into T. So we can write work is equal to V into I into T. So here VIT work is done. So this work done by the source or by the external voltage appears in the form of heat. So we can write here this work appears as heat. So we can write H is equal to V into I into T. Also by Ohm's law we know that V is equal to I into R. V is equal to I into R. So we can write that H is equal to I square R T. So this equation H is equal to I square R T is known as Joule's law of heating. So we can write here again. So I think it's clear. So this equation H is equal to I square R T is this Joule's law of heating. We can separately write it as that whenever current flows through any conductor, then heat produced in the conductor is directly proportional to the square of current from here. It means if we increase the current by 2 times, the heat will increase by 4 times. Second, we can say that heat is directly proportional to resistance of conductor. It means greater will be the resistance, more will be the heat produced, and if resistance is less, then less heat will be produced. And the third, we can say that heat is proportional to the time for which current flows. It means if current is flowing for longer duration, more heat will be produced. This is clear? Now let us see our next topic, electric power. Electric power. See, we all know that power means rate of doing work. So here, rate at which electrical work is done is known as electric power. Rate at which electrical work is done. So we can write the power is equal to work upon time. Work can also be written as charge into potential upon time. But we know that the ratio of charge and time is equal to I. So we can write the power will be equal to V into I. Also, it can be written as if V is equal to IR by Ohm's law. So power can be written as I square R. Also, we can write I as V upon R. So power can be written as V square upon R. So here we see we are having 3 formulas for power. If in our question voltage and current is given, then we will prefer P is equal to VI. If current and resistance are given, we will use this formula, and if voltage and resistance are given, we will use the third formula. Unit of electric power. Unit of electric power is watt. It is denoted by W. It can also be written as 1 watt is equal to 1 joule per second. Now, we also know that electrical energy is equal to the product of power into time. Electrical energy is equal to the product of power into time. So we can write here electrical energy E is equal to power into time. So we will have unit of energy here. Watt second. Watt second. The most commonly used, the commercial unit of electrical energy is kilowatt hour, where power is taken in kilowatt and time is taken as hour. So that kilowatt hour is also known as unit. 1 unit means 1 kilowatt hour. So that I am writing here. 1 unit is equal to 1 kilowatt hour. It is commercial unit of electrical energy. Sometimes it is asked to define 1 kilowatt hour. So we can define 1 kilowatt hour is the energy consumed by any device at the rate of 1000 joule per second in 1 hour. Again I am repeating that 1 kilowatt hour is the energy consumed by any device at the rate of 1000 joule per second in 1 hour. So that is known as 1 kilowatt hour. We can also convert it into joule. 1 kilowatt hour can be written as 1 kilowatt into 1 hour, or we can write it as 1000 watt into 3600 second, or we can write 3.6 into 10 to the power 6 joule. Means 1 unit or 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joule. So this was all about electric power and electrical energy. Now let us see some of the practical applications of heating effect of electric current. Applications of heating effect of current. First, this heating effect of current is mainly used in all electrical heating devices like electric geyser, electric iron, toasters, ovens, etc. Their heating effect of current is used in heating devices. Heating effect of current can also be used to produce light, as in case of filament bulb. But the main thing in that is the filament, the metal which is used as filament, it shall have high tendency to retain heat so that it becomes sufficiently hot and then it emits light. Also it shall have very high melting point so that it not easily melts. So generally tungsten is used as filament in case of electric bulb, as its melting point is very high. Also its tendency to retain heat is also very high. The bulb which we see, that is filled with some inactive gases like nitrogen, argon, etc. to prevent the oxidation of the filament. That was the second application, to produce light. The one more application of heating effect of current is in fuse wire. Fuse wires are safety wires which are used in our circuit, in our household circuit. Generally they are wires having very low melting point. So whenever current will exceed a limit in our circuit, this fuse wire melt and they will break the circuit so that different appliances may not get damaged. Different fuse wires have different rating, like 2 ampere rating, 3 ampere rating, 5 ampere rating, etc. according to the current which they can allow. Suppose we are having a fuse wire of 5 ampere rating. It means it can allow maximum of 5 ampere current. and whenever current will exceed 5 ampere, that wire will melt and it will protect the appliances from getting damaged. So these are the main applications of heating effect of current. Now let us see some numericals based on heating effect of current and electric power. Now here is the question. A lamp rated 100 watt at 220 volt is connected to mains supply. What amount of current is drawn from the supply and what is the resistance? So it's very simple. We can directly calculate. We all know that power is equal to VI. Here power is given, voltage is given. So current can be easily calculated as power upon voltage. Power is 100 upon 220. That will be about 0.45 ampere. Now second thing which we need to calculate is resistance. So here we are having the value of power, voltage, and we have to calculate resistance. So we will use the relation power is equal to V square upon R, or we can say R is equal to V square upon P. V square, that will be equal to 220 into 220 divided by power, that is 100. So 22 into 22, we will get about 484 ohm. So in this way we have calculated the current and also the resistance. Now let us see one more question. Now here is our second question. Here three lamps which are rated as 100 watt, 200 watt and 60 watt are, and each at 220 volt. They are connected in parallel to 220 volt supply. We have to calculate the total current drawn from the mains. We can draw a circuit diagram also. Suppose we are having here three lamps. This is of 100 watt, this is of 200 watt, and this is of 60 watt. They all are connected in parallel to a 220 volt supply. So here let the total current be I. Here current can be divided into three parts: I1, I2, I3. I1 current goes to 100 watt bulb, I2 current goes to 200 watt bulb, and I3 current goes to 60 watt bulb. So now using formula power is equal to VI, we can calculate I1 will be equal to power of the first bulb, that's 100 upon voltages 220, that will be about 0.45 ampere. I2 will be equal to same, power of the second bulb is here 200 and voltages 220, on dividing you will get about 0.91 ampere, and for third bulb I3 that will be 60 upon 220, that will be about 0.27 ampere. Now total current I will be equal to I1 plus I2 plus I3. We can write as 0.45 plus 0.91 plus 0.27. So that will come about 1.63 ampere. So in this way we can calculate the total current. So now since we have already completed the main topics, you all can practice some more numericals related to heating effect and electric power, and also about series and parallel combination of resistance, and try mixed combination also. And if you have any doubt, you can send your doubt through a message. We will clear your doubt. Till then, practice it. Thank you.